Hi everyone, I'm Sarthak Bharadwaj and I'll be giving a quick introduction to our project on using federated learning in healthcare, and we do it especially for rare disease diagnosis. So as many of us know, healthcare data is very sensitive. Hospitals have tons of valuable patient data, but due to strict privacy laws like HIPAA, HIPAA, they can't just share it openly. That's where federated learning really comes into play. It allows us to train machine learning models across different hospitals or institutions without actually moving the data. The data stays local and only the model updates are shared, so privacy is built in by design. Now, what does this actually means for healthcare? Imagine there are 5 hospitals treating patients with a rare heart condition. Each hospital alone does not have enough cases to train a strong model. But with federated learning, we can collaboratively train a single powerful model across all these hospitals without ever sharing the patient's records. This matters because rare diseases often suffer from the lack of high quality, diverse data, but federated learning gives us a way to bring fragmented data sources together without compromising the privacy. So we can create models that are actually effective in real clinical settings. In our project, we focus on the healthcare data, but this can be replicated in a lot of other scenarios. In our project, the main questions that we focus on is how well can federated learning actually protect privacy in a real world medical settings? Can tools like VAE and CTGANs help generate medical data that looks realistic and works perfectly? And of course, how does a federated model perform compared to a traditional centralized one? For the datasets, we use the UCI heart disease datasets, which combine data from Cleveland, Hungary, Switzerland, and the VA Long Beach. And for implementation, we use TensorFlow federated with 5 simulated clients to replicate a real multi-hospital setting. Our goal isn't just to build a model that works in theory, but is practical and scalable. So I would now pass it on to my teammate Temitope, who will walk us through our model setup, experiments, and the results that we got.
My name is Timmy Topper. I'll be talking about the research part of our project. So, one of our research question says, can VAE and CTGAN generate realistic synthetic medical data? I would say yes. In this case, that's what we tried. So there are various models to generate synthetic data using a standard library called CDV, which is called the Synthetic Data VAT. So there are various models to generate synthetic data sets, but we picked the best 2 presently from the from the generative AI. So that's what we use the CTGAN and we use the VEA. The full meaning of the CTGAN is the conditional tabular generative adversarial network. Why the VEA is called the variational autoencoder. So this helps us generate data set that looks exactly like the real data set. So we are working with the art data set like my colleague said earlier. So after our evaluation, both models achieve 100% data structure and validation, meaning that the generated data sets maintain proper format and the stigma. However, in terms of column and shape and pair threads, for CTGAN capture an accuracy of 78.80%, while the VAE capture it 78.17%. After all evaluation, the overall accuracy for generating a synthetic data set is 85.31%, while for the CTGAN is 85.12%. We apply a federated learning approach to train our model using those various datasets generated from both the synthetic dataset generated and the real dataset generated. We want to check the accuracy of each dataset and see how the synthetic dataset works compared to the real dataset. So this is the model architecture for setting up the federated learning setup. So we use the framework used is called the TensorFlow federated, where we split our dataset into 5 clients for training. This setup reflects a real world scenario where medical data may be distributed across hospitals, because each hospital won't want to share their data with other hospitals for privacy reasons. So the model was trained over 10 communication runs, sampling 3 clients per rows to mimic the real federated settings. We compare the performance of the real federated training on synthetic data and the real data. As shown in the table, the real data sets outperform both the synthetic versions, both the CTGAN and the VAE data, with an accuracy of 98.20%. This demonstrates why synthetic data cannot fully replace real data sets. They can serve as an invaluable alternative in privacy-sensitive environments, especially when real data access is restricted. We are still trying to work on the centralized model, the non-machine learning model, to see the performance of all the data sets. So that's the only thing left for us to do now. Thank you.